Hello friends, in last lecture we have discussed about ray diagrams. Here in first ray diagram, which is parallel to principal axis, will pass from F. In second, which pass from F, will be parallel to the principal axis. And in third ray diagram, which pass from optical center O, it will pass out without any type of refraction. With the help of these three ray diagrams, now we are going to form different type of images by putting object at different places by convex lens and concave lens. Here we are having convex lens. Let's study it. First we will have a ray diagram. In second column we will have position of an object. Third, position of an image. And here we will have nature and size of an image. Okay, so let us see how it is formed. If in first case we place our object at infinite distance, means when the object is at infinity, what will happen? Let's see. So if the object is at infinity, the first ray, which is parallel to principal axis, which we can see, so parallel to principal axis, right, it will always pass from F at another side. Here we can see parallel pass from F, the another right ray we are taking, which is also parallel to principal axis. Okay, so it is also going to pass from F, right? So here we are getting, so where we are getting the image, if the parallel light rays like this, it will intersect at F2. So our image will be formed on F2, right? So if the position of an object is at infinite, so position of an image, it will be at F2. How our image will be? Here it is really intersected, yes, so the image will be a real, it will be inverted, and it will be very small, so it will be extremely diminished. Okay, now let's see the second ray diagram. Here also, if the object is placed, here you can see that it is beyond 2f1. Here we are drawing the object, suppose it is AB, it is beyond 2f1. So if the object is beyond 2f1, so our position of object, it is beyond 2f1. So let's see the first ray, which will be parallel to the principal axis. Here it is parallel to principal axis, it will always pass from F2. So let us make it pass from F2. Okay, like this. Second, which will pass from optical center O, right? Here we are seeing that it is passing from optical center O. So let us make it pass from optical center O. Where it is intersected, we will draw their image, so that will be our A dash, B dash. So where our image is formed, it is between F2 and 2F2. So it will be between F2 and 2F2. How the image is, it is really intersected, it will be real, it is inverted, and it is smaller than the object, so it will be diminished. Okay, right? So in our first case, and this is our second case. Now let's see the third case, but again parallel first case, second case, which is beyond 2f1. Now let us see the third case. Here it is our third case. In third case, we will place our object on 2f1. So our object is on 2f1, right? We are drawing our object like this. Suppose it is at 2f1, and here it is AB. Okay, first ray which is parallel to principal axis, like this, as you can see, that parallel to principal axis. Okay, it will pass from f2 at other side like this. Okay, now passing from optical center O, right, where it intersects, at that point we will try to place a image. Here we'll get A dash, B dash. Okay, so here the point of object, it has 2f1, so where we are getting the image, it will be at 2f2. How are images? It will be real, it will be inverted, and it will be same in size. Okay, so the object size and the image size will be same, so it will be same in size as object. Fourth case. In fourth case, our object is placed between 2f1 and f1. So when the object is between 2f1 and f1, what happens? Let's see. If here the object is placed between 2f1 and f1, our object is AB. So first the parallel light ray, right, the parallel to principal axis, okay, will always pass from F at another side, so it is going to pass from F2. Here we can say it like this. Okay, the another light ray, it will pass from optical center O. Let's see. So when it's passing from optical center O, where it intersect, at that point we will plot our image, and here you can see that it is beyond 2f2. So where our image is formed, and here also you can see that the image is large. So the position of an image, it is beyond 2f2, and it will be real, it will be inverted, and it will be big. So it will be magnified, it will be enlarged in size. Okay, so this is our third and fourth case. Now let us see case 5. Okay, in case 5, if the object is placed at f1 like this, our object AB, it is placed at f1. So position of an object, it is at f1. Let's see where we are getting the image. So first ray, which will be parallel to principal axis, it will always pass from f2 like this according to ray diagram. Second, which pass from optical center O, it will be like this. Here you can see that object AB, okay, so they are never intersecting each other, right? So it will meet at infinite distance. We can assume that it will meet at infinite distance, and there we will get our image. So position of our image is at infinity. Okay, so image, it will be real, it will be inverted, and it will be highly magnified, it will be highly enlarged. Okay, now let us see in case 6 what happens. Here you can see that if the object is placed between f1 means our first focus, and optical center O. Okay, let's draw it. If it is placed between optical center O and F1, like this object AB, first parallel to principal axis will pass from F2 like this, and here you can see that the second ray which passes from optical center, okay, like this, here we are trying to draw it pass from optical center O. Right here we can say that if the refracted ray it is extended backward, okay, so are we getting any type of image? Let's try to make it. We are extending the refracted ray in backward direction like this. Okay, so as it is extended backward, we will get the image. Okay, here again we are extending the refracted ray. Okay, so at the point where they intersect, there we are getting our image A dash, B dash. Okay, it is between 2F1 and F1. So where our image will be? Our image will be between F1 and 2F1. How image is? Okay, here you can see that image is large. It is virtual because it is not intersect really. We have extended backward, so it will be virtual. So it is erect also, AB, so A dash B, so it is erect, and it is magnified, right? So it is enlarged, so it will be magnified. Okay, now we can study it, have a quick revision. Parallel to principal axis means infinite, we will get it F2, real inverted extremely diminished point like size. Second, it is beyond to F1, we will get the image between F2 and 2F2, real inverted and diminished. In third case, we will get if it is at 2F1, we will get it at 2F2, real inverted and same in size as object. If it is between 2F1 and F1, we will get the image beyond 2F2. It will be real inverted and magnifying. In fifth case, if it is placed at F1, so it will be at infinite distance, we will get real inverted and highly magnified image. And in last case, if the object is placed between F1 and optical center O, we will get it at same side where the object is. Okay, it will be at same side, and by extending it backward we are getting the image, right? So the image will be virtual, erect, magnifying, and at the side where the object is placed. Okay, this was for convex lens. Now let us form images by concave lenses. So first will be our ray diagram, then we will have position of an object, position of an image, and here we will nature and size of an image. Okay, let's see. In first case, if the object is placed at infinity, here we know that it is, if it is at infinity, and here we are having a diverging lens, so it is going to get diverge. So the parallel light ray coming from infinite distance, okay, it will diverge. But when we extend that diverging ray, when we extend that in backward direction, it will always intersect at f1. So the another light ray also parallel to principal axis. Here we can see it is parallel to principal axis. It is also going to get and diverge, right? So this is diverge. Now as we extend it backward, we will get the both of the diverge ray intersecting at point f1 like this. Okay, at point f1. Okay, so from that, if the object is at infinity, we will get our image at point f1. So at f1 means that is our focus on the same side of lens as object, right, is placed, where the object is placed at the same side. We are getting it. How it will be? It will be virtual because we have extended it backward. Okay, as it is virtual, so it will be also erect, and it is very small, so it will be highly diminished. Okay, now in second case, what we can see, if it is at any finite distance, means here we are taking it between 2f1 and f1, so that is the finite distance which is less than the infinity. So if object is right between 2f1 or f1 or at finite distance, right, which is less than infinity, so in that case where we are getting our image, let's see, the first ray which will be parallel to principal axis will always pass from f2, right, but here it is diverging lens, so it will diverge, and when we extend it backward, it will get it at f1. Okay, the second ray which pass from optical center O will get back, okay, at the same path, or it will it will pass without any type of refraction. So here AB, it is intersecting at this point, that will be our A dash, B dash. Here it is between optical center, images between optical center O and f1. So where is the position of an image, where the image is from, if the object is placed at finite distance? It is between, here you can see, it is between focus f1 and optical center, right, but where the side, where at the side where the object is, so on the same side of lens as object. Okay, how it will be? It is virtual, it is erect, and it will be diminished. It is small in size, right, than the object. Okay, so this will be image formation by concave lens. Now from all this image formation of lens and mirror, we will use to know that the image formed by concave mirror, right, it is almost similar to image formation by convex lens. Okay, and image formation by convex mirror is similar to concave lens. Okay, generally we have studied this, right, by mirror and lens. In concave mirror, generally the image is real. In convex mirror, generally it will be virtual. If in concave mirror, it can be diminished, okay, or it can be same in size as object, or it can be magnified, it can be enlarged, right? Okay, so it can be diminished, same, or magnified. While in convex mirror, it will be always small, as we have studied that convex mirror. Okay, now here in this case it can be inverted because it is real, and in virtual it will be always erect. So this can be the conclusion of image formation by mirrors and lenses. Okay, so understand it very well. Thank you.